In the first video, Factor by Grouping, Part 3, we learned how to factor non-monic polynomials, that is, polynomials where the lead coefficient is not equal to 1. We learned how to factor those using the expansion boxes. Some of you will want to know how to do the same thing algebraically without using expansion boxes, and this video is designed to show you how to do that. So let's factor 3x squared plus 5x plus 2. We know that we need two numbers that multiply to 6 and add to 5. Those two numbers are 3 and 2. Now, instead of making expansion boxes, what we'll do is we'll split the x term, the 5x term, into 3x plus 2x, using those two numbers that add to 5. Next, we'll group the first two terms together, the 3x squared plus 3x, and we will group the second two terms, 2x plus 2, together. Then we will factor the greatest common factor from each pair. Notice that the pair 3x squared plus 3x has a greatest common factor of 3x. So we'll factor that 3x out of the parentheses to get 3x times x plus 1. On the other side, 2x plus 2, the greatest common factor is 2. So we'll factor out that 2, and we're left with 2 times x plus 1. If factoring by grouping is possible, and if you do the greatest common factor factoring correctly, the two binomial terms will be exactly the same. If they're not the same, then either this can't be factored or you might have made a mistake. So we've factored the greatest common factor, and now we'll use the distributive property. We're essentially factoring out an x plus 1 from each term, and the result is going to be 3x plus 2 times x plus 1. Let's do another one. And yes, we've already seen how to factor this in the previous video. So we need two numbers that multiply to negative 168 and add to 22, and we know that those numbers are 28 and negative 6. So let's split the x term into 28x minus 6x, and then factor, group them, group the first two terms and group the second two terms. Now this is something that's very important. When you split the x term and the second one is negative, notice that when you group the second two terms, the sign between the 6x and the 21 in this case changes to positive. Now you'll notice that when you expand negative 6x plus 21, that it expands correctly into negative 6x minus 21 without parentheses. But you need to remember, again, that this sign needs to change. Now, after grouping, we're going to take out the common factors. And the common factor in the first group is 4x, so that leaves you 4x times 2x plus 7. And then the common factor for the second one is 3, so that leaves us also with 3 times 2x plus 7. And we can see that if you factor 2x plus 7 out, you find the result as 4x minus 3 times 2x plus 7. Now let's factor 5x squared plus 17x minus 12. We note that we need two numbers that multiply to negative 60, that's 5 times negative 12, and add to 17. And those numbers would be negative 20 and 3. We split the x term into 5x squared minus 20x plus 3x minus 12. And notice that this time we chose to make the split be the negative one first and then the positive, which will simplify things in a moment. We then group the first two terms and the second two terms, and then factor the GCF, the factor the GCF of 5x squared and negative 20x is 5x. So that factors to 5x times x minus 4, plus the greatest common factor is 3, so that's 3 times x minus 4. And then if we just use the distributive property to factor the x minus 4 out, we get the result of 5x plus 3 times x minus 4. You may wonder if it matters what order we put those two coefficients in and what happens if we reverse them. So let's do it the other way. We will now split this into 5x squared plus 3x minus 20x minus 12. We now split, or collect rather, the first two terms and the second two terms. And notice that we did change that minus 12 to a plus 12 as we grouped. We now note that the greatest common factor of the first pair is x, so we factor out the x. And then the greatest common factor of the second pair is 4, so we factor that. And we'll notice that we get x minus 4 times 5x plus 3, which is exactly the same result we got in the previous slide. And this ends part 3a.